Okay, question number 4 comes from chapter 14, which is the binomial. At the Vic market, watermelons are delivered to a storeholder. It is known that 25% are small, 30% are medium, and 45% are large. The storeholder selects 10 watermelons at random. Straight away, I'm thinking binomial. Let X represent the number of large watermelons where X is binomial, N and P. So N is 10 and P is, it's about large watermelons. So it's going to be 0.45. What's the probability that 6 of the 10 watermelons are large? Probability that X equals 6 will be the binomial PDF 6, 10, 0.45 and do it to 4 decimal places. Okay, so interactive, distribution, discrete, PDF. 6 is the number I'm interested in. I've got 10 watermelons that I'm choosing from, and it's 0.45, which is going to be 0.1595677, which is 0.1596 to 4 decimal places. At least 6, probability that X is bigger than or equal to 6 is going to be binomial CDF 6 through to 10, 10 and 0.45 will be the notation. So interactive, distribution, discrete, binomial CDF. Lower is 6, upper is 10, N is 10, and that's 0.45. And that's going to give me 0.26155627, which is 0.2616 to 4 decimal places. Okay, from the 10 selected watermelons, what's the expected number? Well, for the binomial, the expected number of X is NP. So that's going to be 4.5 watermelons because N is 10 and P is 0.45. The standard deviation is the square root of N times P times 1 minus P. Jump on the calculator for that one. 10 by 0.45 by 0.55 gives me that answer, which is going to be 3 square root of 110 on 20, 4 decimal places. So if it says 4 decimal places, that's what I've got to do, 1.5732. And what's the probability the number of large watermelons is within 2 standard deviations of the mean? Okay, so that's going to be probability that X lies between the mean, which is 4.5 minus 2 lots of 1.5732, or 4.5 plus 2 lots of 1.5732. So I've got 4.5 plus 2 times the last answer, which is 7.646, or minus, which is 1.35, which is the same for the binomial of the probability of X is between 1.35. So therefore the smallest number that is bigger than that is 2, and that goes up to 7. So I'm looking for interactive, distribution, discrete, CDF of 2 to 7, 10.45. And that's going to be, to 4 decimal places, 0.94935 or 0.9494. And lastly, the storeholder again selects from the delivered watermelons how many watermelons are needed, so I don't know N, to ensure the probability of at least 1 is larger than 0.999. So I'd like to do a binomial CDF, 1 to I don't know, 0.45, and I'm looking for a bigger than 0.999. Okay, so if I grab this, and let's say I choose 10, and I start at 1 because it's got to be at least 1, and 10's not big enough, 0.997. I try 11, That's also not big enough, but I might show what I'm doing. So binomial CDF 1, 11, 11, 0.45 equals 0.9986. Not big enough. And hopefully 12 will work. And yes, so binomial CDF 1 to 12 to 12 to 0.45 equals 0.9992. Therefore, 12 watermelons are needed. Again, I could have placed an X there, and I could have placed an X there, and I could have picked this up, copy, jump out, go into graphs and tables, get rid of that, paste it into the field that I want, tick it, check my range. I start at 1, go up by 40, that's okay. When I press my table, resize, I'm looking for the first time we are bigger than 0.999 and 12, same answer. So that's question number 4.